This is our tech night. How many we got online? Ah, got a few down on, even Richard from down under. Hello, Richard. Jim McMaster is a member of the club and is into microwave. How many of you remember his demonstration at Field Day? Okay. This, I was surprised that you were making contacts at Field Day. That just blew me away. But Jim has graciously consented to give us a presentation tonight on all the things you ever wanted to know about microwave radio. Jim, turn it over to you.
Thank you, Dave. Yeah. That seems like it was yesterday that we were at Field Day and all that heat and all that jazz. But we were bouncing off of the buildings in downtown Fort Worth. That was our magic, to make the contacts 80 miles away on 10 gigahertz and 24 gigahertz. So we're going to talk a little bit about microwave. Hope you get something from this. We are in the same club as the guys that are in HF, if you will, but it's just a big, broader landscape. When you get up to microwave, there's a lot to choose from and a lot of propagation, neat stuff that happens. And so I'm going to jump right in. And we'll start with, I'm going to display a presentation that's actually not from me. We have about 20 of these we can pick from. But Greg McIntyre is one of our folks that works with us a lot, and he's a club member of the North Texas Microwave Society. We believe that there's a synergy between what we do in microwave and what we do in HF. And so I know you guys are more about HF and VHF and UHF, and there's a crossover here that we could explore and we could maybe leverage. And so that's why we keep coming back to this. So I'm going to see if I can get my computer to work here, and we'll go through this. I have a PDF. So first of all, I wanted to start with the bands and the calling frequencies, and there's a reason for this season here. And so when we talk about microwave, we really believe anything above 902 or 900 is in the microwave spectrum. And you'll see these different bands and their calling frequency. That would be on CW or on single sideband. And so you'll see we have the 2300 allocation. We have the 3300 allocation, 56, I call it 5676, but it's all the way from 5650 to 5925, 10 to 10.5, 24, 47, 76, 122, 134, 241, all above 2. What do you notice about this right off the bat? Is like it just is a lot of bandwidth. So when if you go down here like 5650 to 5925, that's like 300 megahertz. That's 10 times the amount of spectrum that you have in HF. HF goes up to 30 megahertz, right? So this is like 300 megahertz. So there's just these huge bandwidth. It's hard to fathom in your brain and get down that. Now we get up here into the gigahertz, 76 to 81. What is that? That's like 7 gigahertz. That's like thousands of times broader than HF. And it really matters here because the FCC is all about, snatching this away from us. And we see a routine method by the FCC to honor the 5G. First it was 3G, and now it's 5G. It's coming up 6G allocations for these these frequency bands. And, why do they want that? Let me stop a minute to talk about that, because what happens when you get to where you have an application as a commercial designer? There might be some folks here that are in that business. But when you're a commercial designer and you need 100 megahertz or 250 megahertz, or 500 megahertz of bandwidth. Why would you ever need that? Well, you would need that because you're a backhaul operator that wants to market a system that can service cell phones at the same time that it's servicing internet requests coming back into the internet. And these are called diversity systems, right? Because they do multiple things at the same time. Well, how do they do that? They do that with bandwidth. And so they want 250 megahertz, 500 megahertz, and even more. And then they're also moving big gobs of data, which Barnett would understand because it's like internet traffic. It's big and it's wide and it's vast and it's got to move fast. So, and it has to cope with bad conditions. So not everything is perfect, and rain comes and wind comes and dishes move. You see these 30-foot poles out there when you go down the interstate? That's backhaul. And you see those little square panels? Those are backhaul. They're doing, but they move. They move a little teeny bit. So the more bandwidth you have, the better you can overcome these odds, if you trust me. That's how it works. So they want more and more spectrum. And we have it. We have it given to us today already. So we need to keep it. And that's part of our reason for a North Texas Microwave Society. Is just create beacons, create usage, get people on the air, try to help them come up, and be able to show the ARRL, Defense Spectrum Society, that we are using these frequencies and we need to keep these frequencies. I think it's kind of a losing battle, but we're going to keep trying. So there's that little bit there. So the amateur microwave is generally considered to be allocated frequency above 902, available to all amateurs with a technician or higher class license. So you don't have to have a general, you don't have to be an advanced. You can get on these bands with a technician. There's many new technical and operating challenges, which we're going to go into. Most work is weak signal, so it's going to be down under the S unit level. It's out there. And usually it's CW, sometimes single sideband. We are seeing a very strong WSJT X mode implementation. Q65 is the mode in WSJT for terrestrial work, Q65JT9 and JT9 for EME. We'll talk a little bit about Earth, Moon, Earth, and moonbounds, but primarily what we have some big EME operators in the DFW area that have accomplished great things. Primarily, we're interested in terrestrial, breaking that limit that we currently are trying to overcome. And when you get to higher microwave frequencies, just going beyond 50 kilometers can be a big deal. We know there's some FM repeaters at 902 and 1285, and there's amateur TV at 23 centimeters, 13 centimeters, and 6 centimeters. I think this amateur TV is very big in Europe, and I think we have a lot of opportunity here in the United States to explore this more. And it goes towards something that is very dear to me, but I don't know how to accomplish it, and that's how to get young people involved. Everybody here is almost, with the exception maybe of Rebecca, have gray hair, and there's this problem. We have some new young people in the North Texas Microwave Society. We have a couple of under 30-year-old folks, but it's very rare. And I'm looking, I think all of us are looking for ways to engage the younger group and what could appeal to them. I think we have to look at that. We have to look at what appeals to them. And I have a couple of ideas after spending a lot of time with that, but I think TV might appeal. So for microwave stations, fixed station is going to be, equipment's going to be in the shack, like most of us have home systems with antennas on the tower. In order to reduce the loss, you're going to have heliacs or waveguide running up to the antenna. Or you're going to have your equipment in a weatherproof box on the tower and mass fed by the mass fed is the IF signal. Those ideas would be generally limited by the HOA. So what we're saying here is you either have the antenna up on the tower, and then you have waveguide coming down to the shack where the RF is being generated or received. And you have the relay, the transmit receive relay in the shack. Now, even with the best of waveguide going up, and it'll be kind of semi-flexible going up, and then it'll be really flexible that goes around the rotor loop up to the dish. So the dish can turn and the flex and the waveguide can flex. It's still going to be a big loss, at least 6 dB. So you're going to lose half your power or more, just getting to and receiving the signal. So that's option one. Option two is you put all the equipment up on the tower and you have the IF radio, which is going to be like 2 meters. You're going to bring the 2 meters down on 100 foot or whatever it takes to get down to your shack. Now, the problem with that is lightning strikes and it's going to hit. It's just a matter of time. And all your prize gear is up there. And you're going to have to climb, to fix it. And you're going to have to deal with that climb. But it does reduce the loss to a very low amount because you can put some good coax up to get the 2 meter IF down. We'll talk about why it's an IF. Rovers, now that's my world. And I was talking to Sam. This is similar to the POTA approach, the parks on the air or the summits on the air. You're going to launch out from your location. I was in an apartment for many years. So I'm now in my home that I'm going to retire in with my XYL. But you have this gear that you can put in the truck and you can take it out and you put it on a tripod and you can fire it up and you can talk to people. So the Rover has that convenience in that they don't have that tower and all that heliacs and all that. They have it all mounted on a platform that they can put on a tripod. Propagation. This is one of the most misunderstood things. People think about microwave being limited to line of sight. There is a frequency above which it is really line of sight, as far as I know. It is really line of sight. You can think of it about as light, like a LED or there's a difference between LED and a laser. But think about a light that shines. And, if you know how you see the lights of an oncoming car that's below the road that you're driving on? Well, that's refraction. So there is, even in light frequencies, the ability to illuminate something in the atmosphere, probably dust, particles, that lets you know there's a car approaching. Even though they're below the horizon, you can't see the headlights yet. So even in light, there is refraction. There's a way to get beyond the horizon, but mostly it's line of sight. To get the best signal, it's line of sight. But beyond light, when you come down into the lower frequencies, like 10, let's start at 2, 3, 5, 10 gigahertz, 24 gigahertz, 47 gigahertz. All of those bands enjoy some of these other propagation paths. Tropoducting. You guys on VHF and UHF know about this. It extends with the temperature inversion. It's definitely a real thing that we get heating over the ground. That's heating and it's colliding with cooler air from the night before. This is going to be early morning. That's going to create an inversion. There's going to be a little bit of a duct, and that can cause refraction at all of those lower microwave frequencies. So you'll always want to believe in that and trust in that if you're wanting to make a contact. Knife edge refraction, There was a 76 gigahertz context made 2 days ago in Ontario area of Canada. Completely impossible. They published the profile, and there was this big, there was this big ridge right in the middle. Well, it was knife edge. They hit that and it refracted over the edge, and they made it was only 33 kilometers, but they made a contact that qualified as the number 5 grid for the operator, which means he gets VUCC at 76 gigahertz. I think he's either the first or second person in the world to get that honor. That was 2 days ago. And so the knife edge refraction is something that works where there's mountains that would otherwise separate. Rain scatter, the size of the drop, it matters because it can resonate. And when it resonates, it causes the incoming wave to pass through and re-resonate out the other side. So it's like a repeater. And you can actually get gain from this. And 10 gigahertz is the most popular frequency for this because it happens to fall into the general size of the raindrop. And there's studies on this ad nauseum on exactly what size that raindrop is as it falls and separates. It separates into 2 little drops, and then this drop is just the right size. Aircraft scatter. This is more of a nuisance to us in the DFW area because we have so many airports, and you hear this, and it causes a diversion in your ear if you're listening to CW. But aircraft scatter can be employed on a more serious term, and there are actual websites and studies on this where people are, get this, they know the flight paths of the aircraft, and they've got it down on the website, and they show you where to point the antenna to get the bounce off the wide body jet. We're not into that here at DFW, but there are people that make contacts on this. Earth, Moon, Earth. This is a well-known. It's a passive reflector. There's a lot of path loss getting to the moon, and then of course getting back. But we have some key operators in DFW that have accomplished great things through Earth, Moon, Earth, and then reflecting off of water towers and buildings. We just made some contacts this year in the summer where we were using the Cedar Hill towers to overcome a blocked path. So the guy was down in Waxahachie and the other guy was in Burleson, could not contact him direct. But going through the towers on Cedar Hill was able to make the contact. So that's a whole interesting story unto itself.
When you say the towers, Cedar Hill, you talking about the TV towers?
Yeah. Okay. Talk about the TV towers. There's 12 towers, and they are within 1,000 kilometers as a circular circumference. 1 kilometer. I'm sorry, not 1,000. 1 kilometer. 1 kilometer. Those towers that you see, that you see blinking up there, they're within 1 kilometer. We did a study on it. We got a guy did a study on it and said, if you're 30 miles away, your dish is 1 degree wide. It can just barely illuminate that full group of 1 kilometer towers. But it happened. Rain scatter. This is a big deal for most folks that are on microwave because it's the only way they can make a contact beyond a few hundred kilometers. And there's a website called rainscatter.com. This is Andy Flowers is the ham operator. I'm not gonna remember his call sign, but anyway, Andy figured out how to make this happen, and you can sign up. This thing is free, and then you'll be able to put your call sign in and your location. And then you will be able to see when there is a rainstorm cell that's of the height that it will support a long distance contact. we had this storm come up in Oklahoma a couple of years ago. It was to the east, just to the east of Oklahoma City. And we were able to contact WQ0P. The slide here talks about the 419-mile contact, but there were several others that were made. This was a devastating storm. It actually had impacts on people, which was sad. I don't think there were any fatalities, but it really tossed a lot of problems just east of Oklahoma City. But in the meantime, we were all out and making contacts off the leading edge of this storm. Rain scatters definitely important. So just a couple of notes about Microwave Society, formed in '86. I think Cowtown's older than that by a good bit. So we're a little late to the party, but it's about the exchange of ideas and technology. I'm the president. We have Vice President Scott Armstrong, and Secretary, Treasurer, and website guy. And, we just try to get together on a regular basis. There's a web page here. It shows some of our homepage here, and then some of our activities, monthly meetings. We have in-person meetings about 4 times a year. We don't have this great venue that you have here, which I really appreciate. I've come to really appreciate. We have to schedule the time at a library, and we can't schedule the next meeting until we consume a meeting. So we never know where the next meeting date is going to be. And then it's a great venue altogether, but it has its problems. The price is good because it's free, and we don't have a very large membership. So I know you can appreciate that, because when you don't have a large membership, then you don't have a large budget, and you have to protect what budget you have. And that's how we're ending up at free venues. We also pay, for the defense fund every year. We chip in $300 or $500 to the ARRL defense fund, and we have Zoom costs, and we have website hosting costs. So there's a baseline budget where we have to acquire a certain number of members that will pay. We do these other things. We have the noise figure and network analyzer test sessions at meetings or at members' houses. We have an antenna range for measuring antenna gain. We help many people with equipment construction, contesting. We have a couple of contests through the years where they're microwave specific. We have some social events that we go to, and then sponsoring Microwave Update. So I wanted to take a moment away from this slide just to let you know that, this might be your thing. I don't know, but I have a couple of props here, sort of, and that is we always attend the Central States VHF Society. There's a group of us that attend this, and we submit the papers. These are the proceedings, so that's all of our papers, that ideas that we're going to share with the group. A lot of it's new information, and this is, we held the Central States was held in Cedar Rapids in July, late July. I took one of the new people in our club, a young man, about 25 years old, just graduated from Eastern State University in New Mexico. He rode with me and shared the driving duties up to Cedar Rapids, and got to experience his first conference. And he got paid at the same time that we were there. So he was just like, can't wait to spend that money, right? And he bought a bunch of stuff, and he had a good time. But we brought some demonstrations up there. We demonstrated tower bounce at 47 gigahertz out in the parking lot. They have a thing they call Rover Row, where we bring our dishes and we set them up. And he was stationed about 5 miles out to the north, and we had found a tower that was out there to the north, and we both aimed at that tower and demonstrated to a crowd how we could bounce 47 gigahertz off that tower. There was no doubt, that it was bouncing off the tower. So that's Central States. All these conferences generally cater to the primary operator and the XYL. And so you sign up for these things and bring the better half, and there's usually a family program that will go off and explore the local interesting points. And so I'll talk about that next, and that's a microwave update. This is held every year at some point in the North America area. This year it was in Vancouver. So we went to Vancouver, and I did 3 presentations. We had another member of our microwave on the XYL, went on a local tour of Vancouver, out to an island where they watch the whales and all kinds of good stuff. And so these are interesting things to participate in. There's the, the proceedings where we, if you type in microwave update 2024, you'll get to see the biographies of all the speakers and so forth. We have a good time here. It's a good time to relax and also just share the new things that we've learned. At DFW, the NTMS, the North Texas Club, has sponsored Microwave Update 5 times. The last time was 2019. We're going to come up again about 2027. We'll be sponsoring the next one in 2027. So the NTMS has these, the weekly lunch at Texas Smokehouse Barbecue. And then we have these beacons. I want to talk about these beacons for a minute because these things keep going all day and all night, 24/7, 365. Got to 50 megahertz, 2 meters, 222, 432, 901, 903, 1296, 2304, 3456, 3400, now that we've been booted out of 3456, 5760, 10 gig, 24 gig, the 47 gig is under construction right now. We have a couple of units that we're working on right now, but all of this where you see it's on the air is on the air. And these are tower installations. The Denton, which is the EchoMike 13 kilo Foxtrot. Anybody understand what that grid means? EchoMike 13 kilo Foxtrot locations. Those are on the women's dorm at Denton. Yes, thank you. And so those are all signing Whiskey 5 Hotel Nancy, stroke B. And they keep running all the time. And, we have folks that join and they say, well, I'm listening to the 902 beacon, and every now and then these beacons will get stuck where they just go, burr, and so we have to reset them and reboot them, but they've all got remote control power supplies. And we're, like I said, we get down to 24 and 47. We're working on these right now. We have a project where we're going to put 2 of them out, 2 that will both be 24 and 47 combined. And I was interested in what Fred had with the crank-up tower, because I bought a crank-up mast. I think I wouldn't call it a tower. It's a mast that will go up to 27 feet. And so it's on a trailer, and I can haul it with my truck, my wife's truck. And so I haul it out and I deploy a 47 gigahertz beacon on the thing. And we've been testing with that the last month, just to learn what we do. We have very little knowledge of what propagation effects occur at 47. We have some results, but we don't understand why. And so we're trading that information with other people around the country to see what they know. We tell them what we've experienced, but we still don't understand exactly what's going on at 47 gigahertz. We have these Sunday night nets. There's 144.260. I think Mike has this on your list. So, and then we have these tune-up parties. This is a guy, N5 BRG. He's got this enormous, we call it ranch, really, out in near Pilot Point. And we meet out there about once a year and just bring our antennas. We do a tune-up, and you get Kent Britton on the right side there, one of the premier guys that can measure antenna gain, and he will measure the the gain, and then that. So there's FT8 activity nights for the digital operators that like FT8, and then. So let's talk about getting on microwave. Just a quick review. I did show these at field day, but I'll go through them again. So you will have some kind of a VHF. You'll need a VHF multiband, sideband, or CW transceiver to connect to a transverter. ICOM 7300, IC 705. And then the transverter, we use a local oscillator and mixers to up convert from an IF like 2 meters to an RF frequency like 10368. As an example, an LO of 10-224 megahertz can be used to mix with 144 to achieve 10368. And so here's the pieces it would take to do that if you went and cobbled them together. The only thing about this is that it's going to take, this much space. It's going to take some space to get these units and put them together. This particular system has a 3-watt amplifier, isolators, mixers, and power dividers, a low power amp to get the signal up to the level that the 3-watt amp can amplify, a waveguide filter to eliminate harmonics, which are going to be many, and then a low noise amplifier that will give you some receive gain. And then you will need, here's a couple of options. This is filtration on the left side. W1gigahertz.org makes these here, which will give you ability to, what you're trying to do here, if you could imagine a spectrum analyzer, and you've got a sweep from 0 to 20 gigahertz, and you see all this hair on the thing. Well, you want to get rid of that before you amplify it. You want to try to narrow it down to something close to the fundamental frequency you're trying to pass through. And you've amplified it many times. So you've got all these harmonics off the original LO. And that's what these pipe cap filters do. I mean, it's an ingenious thing that basically will have on the bottom side of this board, it's going to have a pin that sticks up. It's a straight pin, like you use when you sew things together. You have to pin material together. It's a straight pin, and it's coming in from the bottom. It needs to be a certain length, so you're going to have to cut it off. But it's going to come in from the bottom, and then there's a bolt that comes down from the top. And when those two get to the right spot inside that cavity, they are a bandpass filter. And so as you neck those down, you see them going from tall to small. You clean up the signal more and more and more until you end up with something that's legit. It's not going to be against the law to put out on the band. Now on the right side, this is a down east microwave, which I highly recommend. I'm not connected, but highly recommend it. If you want to get on 10 gigahertz, you just pay these people to build the thing, because I've built them from kits, and I've fixed them from people that bought them as kits, and it's just better to let them build the damn thing because they just do it right. The problem with the down east microwave is it's like a 0.5 millimeter Teflon board, and they have you bolted down to this 1/4 inch thick heatsink. And once you bolt that Teflon board down to that heatsink and try to solder stuff on it, it's heat sinking the heck out of it. So it's very difficult. You have to put it on a warming plate, and everything's hot, and you're trying not to get burnt, and you use hot air, and all, it just turns into a big mess. So it's better. It only costs $100 to have them build it. So you just pay them, and you're done. Here's some local oscillators. Everything starts with a local oscillator. So you got to have something create your fundamental frequency that can then be, you can pick the harmonic off of. That's how everything works. Only in microwave, it's really important because we're going to take the 12th harmonic, So there's all these different choices. There's many choices. I even found some on Amazon for about $50. that have harmonics that are clearly receivable and detectable all the way up to 150 gigahertz, 150 gigahertz. So it's not a big deal here to find a local oscillator board. Here's one that some club member made. It was built by Al, W5LUA. It's using the ADF 4351. I think many of you know about this already, but the ADF 4351, there's an app for that. Analog Devices actually publishes it. I've got it on this computer. And you can just tell it what frequency you want. And okay, if you want to get to 10 gigahertz, you're probably going to use a frequency like about 3,300 megahertz. And you just type that in and you press it and it says, I'm going to write these registers with these values. And if you got this connected, it writes the registers, out comes 3,300. Now, 3,300 times 3 gets you up there. Now you're up to 10,224. You mix in 144, you get 10,368 out. That's how simple this is. It's not hard. It's simple math. Here's on the left side is a DB6NT Cooney 10 gigahertz transverter. This is actually an earlier generation. They've got one that's later than this, but these are about $700. They'll run about 300 milliwatts. Probably got to want to add an amp, but you can still accomplish a lot with 300 milliwatts without an amp. And they take about a week to get to you. You know, they're still in business and they do it quick. Now to the right is the Down East version. I recommend this. You can get a 3-watt version of this with a built-in preamp. The thing with Down East is they got hit by that hurricane. They're in I can't remember the name of the city, but it's on the west side of Florida, and they got hit by the hurricane twice. This just in the last few months, so it blew the roof off their plant, and they've been getting it back together. They are taking orders again, but I recommend this. You usually get a lot for your money. It's about $700 built, and you'll get everything you need there. Here's some antenna options. This is some cool stuff here because you can reuse satellite dishes, and that's what we recommend. You can homebrew the feed horn. It's not hard. You just get a piece of 3/4 inch OD copper pipe from Home Depot. You got to buy a flange that will go on that, or a backstop. You have to mount an SMA connector about 1/2 inch from the back of the backstop. You're in business. I mean, it's not hard. It's not hard. Now, when you get up to the higher frequencies, it gets a little more dimensional tolerance wise. It gets a little more critical. Now, this is the 24 gigahertz transfer. You guys maybe heard me talk about this. We, as a club, me and TMS, we took on the role of ordering these boards from China, and now we have shipped over 150 since we started. I don't know why we signed up for that, but we did. And this guy built one of these. Got this neat, cool little analog meter. I love that deal there. If you're old school. So he's got about a 1 watt plus 28.5 dBm. That's a little shy of 1 watt. This will go a long ways when you put it to a dish where you amplify at 40 dB. You'll like 5,000 watts. And so he's got a 144 megahertz input, a waveguide output, and a push-to-talk input, and some power supply, and there's the inside. The green board in there is the thing that we're producing as a club. And we order these from JLC PCB. Anybody heard of that? Yeah. We order them from JLC PCB. And the problem is, when you deal with JLC PCB, they always have a crap ton of parts they don't have. So you have to order them ahead of time. So you have to pay for them ahead of time. And so they never have the synthesizers, they never have the mixers, and a handful of other parts. So you have to go and you have to deal with that and then pay for those. And then they take a week, 2 to come in. And then they're in your virtual inventory. And then you can place the real order, which is make me 15 of these pre-CD boards. And so we keep going through this cycle. Like I said, we got about 150. We had one point where we ordered 70 boards. Now we're down to 10s and 15s as the orders come in from all over the world, really. Folks are still building these. What are they putting this into use with? They're putting it into use with a module that does the RF work. This green board, it's mounted on that module. The green board is just the power supply, the control circuitry, and the synthesizers that produce the LO frequencies. The module underneath has been harvested out of an outdoor unit that's at 23 gigahertz, 23. And so it's been on a tower. They've taken it down. It's been salvaged. There's a guy in Poland that has a bunch of these, and he takes that module out and he sells it on eBay. So we buy that module, we add this green board that controls it, we implement it at 24 gigahertz for use, terrestrial use, and EME. So when we get an order for one of these, the guy will have to tell us what his IF frequency is. It's going to be 144 or 432. Those are the two popular IF frequencies. He's going to want to ultimately attach a radio to it that is going to be operating at 144 or 432. And he has to tell us what his ultimate frequency is. In Europe, it's 24048. In America, in North America, it is 24192. And I program the AT Tiny 85. Anybody know what that is? AT Tiny 85 to write the registers so that they will produce those frequencies. Ship it off. Take it down to the library, take it down to the post office in Burleson and ship it off. The major event for NTMS to participate in the contest August and September. This is the thing that we aim to have all of our gear ready. And, you know, there's always somebody that comes into the fold about July, and they're trying to get their stuff ready. And the first contest is in August. So it's always a big rush. You always get together and huddle and try to get that person up and on the air for the August contest. Some stations operate from home. A number of stations are rovers. The object of the contest is to work as many stations in as many 6-digit grid areas as possible. The rovers have to move at least 10 miles or 16 kilometers as the crow flies before a station is reworked, and so on and so forth. Here's a WA5 YWC, a good friend that is now an SK. This guy did I'm going to have the most power on the band and still be in a truck. So I think that's cute because not very many people do that. But he has got flexible waveguide here, and he's running what's called a TWT, a traveling wave tube. So he's got like 100 watts on 10 gigahertz. That's just incredible. But, you know, we heard him real well everywhere he went, Bob. And here's some of his stops to give you an idea of what a rover might do. They'll travel all around here. If you know, my strategy is more to stay. We try to go out long for one of the weekends because there's 2 weekends in the contest, and then we try to stay in close one of the weekends so that we can do the really higher bands that have more of the path loss problems. And we can't use those out beyond 100, 200 kilometers. Here's this looks like 24 gigahertz setup that looks like Queen Wilhelmina. If I have that right, that's what it looks like. So you can see that big widespread tripod and a 12-inch dish there. And then here's the guy, Scott. He still operates this way out of his back of his pickup truck. And this is at his home. He just pulls it out and sets it up on his tripod there in his truck. Here's an attic installation. This is an offset dish. So it's, you know, as opposed to tripod, prime focus. And Al has worked MW5LUA at over 200 miles. Here's again, Scott, 47 gigahertz setup on his tailgate. Um, he's running -7 dBm, that's 200 microwatts, with an antenna gain of 15 dBi. Here's a setup, 276 gigahertz transverter, and you can see we have a limitation on 76 gigahertz of 315 watts effective effective radiated power, uh, and that's because we share the band with other Part 15 devices, and primarily right now, if you don't know this, 76 gigahertz is it's really the new automobile, what do they call it, driver assisted. It's basically the radar that will, when you try to turn your turn signal on and there's a car back there and it goes beep, 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 that's 76 gigahertz. And so, we have been limited on that band to 173 watts of effective indicated, I don't know what that stands for, but it's basically we got to hold it down. We got to hold down. So you see the little tiny horn over here. There's a waveguide. So there's a lot of trouble. A lot of trouble goes to making this setup. So we know that the microwave bands offer us technical challenges, operating challenges, just like what all of you do. You have some form of a challenge, just like we do. The microwave bands are little teeny wave lengths. They require dimensional accuracy as you go higher. You can make a lot of that stuff. I've built a lot of stuff in my lab, basically with a vise, cutting up brass pieces and that kind of thing. But it tends to want to have more dimensional accuracy to get the best quality. Whereas if you're making a 40-meter dipole, you can probably be a couple inches off. And it might change. The SWR might change with the amount of moisture that's on the wire up in the tree. So there's those comparisons, but the challenge is still there, and you are trying to accomplish some DX, and or just for me, like I was talking to Sam, my only CW activity until I'm out there doing the microwave thing is I'm working POTUS stations every day. I just get home from work, I'm blasted, it's 5 o'clock, I'm tired, I'm sick and tired of everything. But I go in and turn on the rig, and I open up my phone and I look for the POTUS spots, and I see if I can hear any of those guys. I can always hear one or two, and I work them on CW. So it gives me fulfillment that, I can still send CW, and my rig is working, and the antenna's still working, and that. So it can be that basic. Roving can get you on the bands if you're limited by the HOA. That's what I do. I do roving. If you were to talk to my XYL, she would say, I don't go out there, because it's like a line of dishes, like 6 dishes. And then you go to the next layer and it's like a work excuse. It's a mess. A lot of resources in the North Texas area, so you want to get active on the microwave bands. And I got a couple of other things besides these props I showed. Oh, this gets so harder and harder. This is the one I'm most proud of. Is that we had this record. This is a record. 59 kilometers on 47 gigahertz. This is not me. This is my roving partner, Kilo India 5 Echo Mike Nancy, Paul Sarver. And he's got a 47 gigahertz rig, and there's a cell phone, and there's his ICOM 705. And we were so excited to get this contact in the books, because this is out near Greenville, and we're working a guy back in Allen, Texas, which is in the metro mess, and there's so many tall buildings, junk, that you've got to go through to get back there. And this was such a weak signal. There were repeats back and forth. It went well past dark, and finally we got the signal report, got the call signs, got the Rogers we were able to put it in the logs. We thought that was great. Then came this one. Obviously, I need to practice my prop stuff. Then came this one. 99 kilometers on 47 gigahertz. And this was up in the LBJ grasslands near Alvord, Texas. And it was out of the blue. We drove up. This is one of my partners here, Matt Kuby is his name. He's holding down the 10. This is the 10 and 24. It tends to be a big sail in the wind. And the 47's over here. We drove up to this location. It's a long winding road way up this mountain. And I looked at the humidity and I said, this is not a good day. It's not a good day. It was 70% humidity. I said, this is just not a good day. And we got on the air on 10 gigahertz and we made a contact back into DFW. And the guy that I was talking to said, switch to 47 right now. And so we went to 47 and by gosh, it worked. And so this was a record, new record, 99 kilometers at 47 gigahertz. And so this was kind of the horizon. And this is the secret. This is really the secret is you want to have a clear, right, it's kind of maybe hard to see here. This is right at sunup. And really you want this, you want to look out and see it go like this, you know, like that. You don't want to see it go like this. You want to see it go like this. And when it goes like that and it drops off, the chances are real good that, you know, there's a thing called the Fresnel zone. Anybody know that? Fresnel zone. And it really has to do with developing that football-shaped signal that comes off the front of your antenna. So when you give it a chance, instead of driving it in the dirt, you've got a chance. Basically, you've got a chance. And I'm still a little puzzled about how this happened, but it did happen. And we're very proud, as you can see, that it did happen. I have another one here. This is the last one I'll show. This is the guy that went all over creation, KA6U on 432 as a portable operator. He's got a little dish over here. And he activated all of these yellow states here. People do this, and they don't get paid. It's like, well, if you paid me, maybe, you know. But he went to all of these states and activated, lit up, you could say, lit up the moon for 902. And we have a guy in DFW, W5LUA, that earned the #1, worked all states on 902. So you can't do it without EME. Because at that frequency, you can only work maybe a few hundred miles at best. And so this was accomplished through EMA and the persistence of a rover that cared enough to give of his time for a year or two to go out and do it. And then, you know, the other people at the fixed stations to work him. I imagine they pitched in some money somewhere along the way, but I think it's an interesting story, so I made the prop here so you could see it. And that's all I got. Thank you for your attention. I appreciate the opportunity.